Hi everybody, it's Mrs. Dinkelman. We're getting into the sections from Unit 8 that are talking about volume, and we're going to do the cross sections one first. So this is when they give us a shape on the bottom, so you can see the pictures here. And in my mind, what's happening here is out of that shape is popping up different other shapes, basically. So triangles and squares and semicircles and all kinds of things. Sometimes it's really hard to visualize what that 3D shape would look like. So I have just a couple pictures here. What I want us to think about is before, when we were finding area, we were looking at just an infinite amount of rectangles. So if we could figure out what the height of the rectangles were, and again with an integral, that the width of the rectangles was really infinitesimally small, or basically zero, but that's what our integral finds. So this just kind of takes it one step further. If we can find the area of this shape that we're talking about, and we think about the thickness of them being infinitesimally small, and we add up the infinite amount of them, that's what the integral will find for us, is the volume. So you can think of in the formula for volume is that we have this area, and the dx or the dy is really the third dimension, which makes it volume. So that's what we're going to try to do here. So you're going to want to graph the region. That's the base, so you can see it. You may want to try to sketch the solid, or I like to try to sketch what's kind of popping out. Most people look at my drawing and think, I don't know how that helps her, but for some reason it helps me. It helps me also determine if it's going to be a dx or a dy. Then what I like to do is just assume that these are really strange loaves of bread, and we're going to take a slice out, and we're going to lay it flat, and we're going to see if we can find the area of that object. It really needs to be a generic area formula that would find us the area of any slice we had chosen. And then once you have that area formula, you just write the integral down. So let's talk about what happens with these two. So we have squares and we have equilateral triangles popping up out of this shape. So let's draw a little picture first. Again, sometimes this is just for my own benefit. If you don't need the picture, that's fine. So we're going to have x plus 1, and I'm just going to kind of eyeball that a little bit. Okay, x plus 1, x squared minus 1, so down here, something like this. And let's go ahead and figure out where those two things intersect right now, just so that we have that. These are perpendicular to the x-axis. We'll draw that in a second. They're going to go this way, and that helps me determine that this is going to be a dx, because the thickness right there is how the x changes. If I change it bigger or smaller, it's changing the x coordinate. Okay, let's figure out where they intersect. So I want to know where x squared minus 1 equals x plus 1. So that would be where x squared minus x minus 2 is 0. So x minus 2, x plus 1. So negative 1 and 2. And that makes, I guess, somewhat sense. Again, I just sketched, so I could be off. So with squares, again, I kind of like to draw a little picture that what's popping up out of there is some squares. Again, that might make 0 sense to your brain, but for my brain that works. And I like to take a slice out and lay it flat. And what I imagine happening, let's erase that so that doesn't get caught on there. What I imagine happening is the bottom part of that shape. Okay, there it is. The bottom part of this shape is the one that's laying, okay, is laying in between these two curves, okay. It's sometimes still helpful to think about top minus bottom, just like we would have done in area, so that we can find the length of this shape. So the line is on top, so this is going to be x plus 1 minus x squared minus 1. That's going to be that side, and since this is a square, we know both sides are the same. So I'm just going to write my area formula real quick. So for the area of this square, I'm going to simplify this a little bit. It's going to be negative x squared plus x, and then plus 2 squared, okay, because each side and then multiplied by itself. So now I can write my integral. So if I have my area, I can write the integral. So from negative 1 to 2, and this area formula goes in there. My dx is really necessary to make sure that's a volume, but we all know if you forget the dx, you're still going to calculate the integral, right? Okay, so instead of squares, if they're equilateral triangles, so popping out of here is a triangle. Again, in my brain, as I'm drawing these, I imagine that part is the bottom part of the equilateral triangle. And the sides are the same. So that's still negative x squared plus x plus 2. That's the simplified version. And here's something to remember. This is helpful because if we want to find the area of this, one option is to drop a height, an altitude, and to split that thing in two and do some sort of Pythagorean theorem or something, or trig, to figure out what that height is so that we can do base times height divided by 2. The other option is to remember, if you didn't know already, to know that the area of an equilateral triangle is the square root of 3 over 4 times the side squared. Part of that 4 is from the area of the triangle. The root 3 over 2 then would be from the ratio because of the, this would be a 30, 60, 90 triangle if I kind of cut this in half. And so that comes from that root 3 over 2. So my area formula for this one then is square root of 3 over 4 times that side squared. So let's write our integral. Negative 1 to 2. I'll put the square root of 3 over 4 out here. And then my side squared. Okay, so again, my advice is to kind of lay that shape out and see if you can figure out what the area is going to be. Okay, so this assignment is set up so that you can kind of draw an overhead view or at least have the shape in there. This cross section and areas where you really drew your strange loaf of bread, and then just the volume integral, not calculating all the way out. These first few are all perpendicular to the x-axis, so they will be dx's. I just want to bring your attention to it suddenly changes to y-axis, and I know the first time I did this worksheet when I was making a key, I totally just missed that it said y-axis there. So just don't forget, those are going to be your dy questions.